So let me quickly revise what we have studied in the previous class. So basically we are comparing topologies, that which one is stricter, which one is finer. And in I have discussed one of the lemma, compare two topologies if the basis generating those topologies are given. If the basis generating those topologies are given to you. So for that, so here we have seen that collection of all rectangles, correct collection of circular region. This one is going to form the basis for the standard topology on R2. Okay, but you can see that basis members are here circular regions. In fact, interior of circular region with this open disk, but their intersection need not be, but their union need not be a basis member. You can see here that this one is a basis member, this one is a basis member, but when you take its intersection, then it will be this whole portion. It will be this whole portion, and this one is not an open disk, or you can say interior of a circular region, interior of a circular region. So union of basis member need not be a basis member again, but union of basis number will be a member for the topology which it is going to generate. Just like here, you can also see that this one is a basis, this one is basis, but their union, this is not a basis. So these are the important observation you need to take care of. And this also we have seen that one collection of all one point set is going to discrete topology. Go through those lectures and revise all this concept, because I'm going to use it in all convergence and everywhere. Another important result is that if X is any topological space, here in general they have now start writing X be a set. Here basically X is equipped with a topology T. So, and suppose script B be a basis for the topology T on X, then T equals the collection of all union of elements of B. In general, I can say that every open set can be written as union of basis members, where X belongs to U. And this I will come later on. Basically, I will explain this lemma with the help of one question from exercise, but after this one. So this is the technique. This lemma is very important. Why? The role of this lemma is that suppose script B and script B dash be basis for topology denoted by script T and script T dash. I will read here simply T and T dash respectively on X. Then the following are equivalent. That whenever to show that T dash is finer than T, T dash is finer than T, we need to show that for each X belonging to topological space, for each X belongs to topological, and for all basis member containing this X from script B, and for all basis member, for each, if it fills for one of basis member containing X, then we will not claim for this comparability, I mean coercer finer. There is a basis element B dash from script B dash such that X belongs to B dash and B dash is contained into B. So if we have always around each X and for all B containing X, if we have B dash, at least one member B dash from script B dash, from basis B dash, such that X belongs to B dash and B dash is contained into B, then we will say that the topology generated by this, I mean basis, whose members is B dash, is going to be finer, Then the topology generated by this one. Topology generated by this one is going to be coercer. So I will come to its proof later on. First we will let us try to implement it, this lemma, and then I will come to its proof. Now another important result. Okay, is someone waiting? Let me check. Okay, 3 people are then in waiting room. Okay. So this is the technique. Basically, if I am able to show that T dash is finer than T, and then show that T dash is finer than T. See, if T is finer, if T dash is finer than T, this also, we can also say that every member, see, the member of topology are always said to be open set. By definition, we will always assume that once it forms a topology, its every member will be called as open set. So all those sets, all those open sets, all those sets which are open with respect to the topology T will be also open with respect to the topology T dash. If T is contained into T dash, it means every member in T will be in T dash. So if all those members are in T dash, means all those open sets with respect to T will be also open to the topology T dash. And if this will happen, then we will say that all those open sets which are open with respect to topology T dash will be also open with respect to topology T. So if both happens, then we will say that both topology are equal. Both are generating, those bases are generating same topology. So example for this one is this one. Example 4. Two bases are given. Say B is going to generate, script B is going to generate topology T, and script B dash is going to generate topology T dash. Now, when we will say that, see, these bases may not be equal, these sets may not be equal, but they may generate the same topology, For example, suppose we have collections B, script B of all circular regions in the plane, and earlier we have seen that they are going to generate the same topology as the, we will see, I have already discussed that they are going to generate the same topology as the collection B dash of all rectangular regions. Why? Because around each X belonging to X and all those rectangular regions containing these X, one can always have a circular region around this X which is sitting inside this circular rectangular region. And same I can do here. So the topology generated by this circular region is going to be finer than the topology generated by this rectangular regions, interior of rectangular regions. And from here we have that around every basis member, for all those basis member whose members are circular regions containing X, one can always enclose rectangles inside these open circular regions. So the topology generated by this smaller one is going to be finer, So since both side containment is there, so I can say that they will going to generate the same topology. Remember that these are the bases given to you, not the topologies. These are the bases given to us. And whenever basis given to us and using basis you want to compare that which topology is finer, which one is coarser. So you have to apply this theorem. You have to apply this result, because this is the result which will be used to compare the topologies, So unless either T is contained into T dash or T dash is contained into T, only then if this happens, then only we will say that topologies are comparable. If this is not true, then we will say that topologies are not comparable and we will never use the term coarser and finer. That already I have done. So till now I have covered. Now let me recall once again that we have seen the collection of all, notice this word. Collection of all open rectangles in the real line is going to generate the standard topology on the real line R. And this collection of all half open intervals, this is going to generate the topology called as lower limit topology. All these examples are very important. We will use it at several places. When I start discussing this convergence in topological space, I will use all these basis members. Convergence, for example, suppose you are asked to show that whether 1 by n is convergent to 0. I will come to that chapter. But see, up to now we have studied in metric spaces and real analysis that 1 by n will converge to 0. 1 by n will converge to 0 under usual metric. But in topological space, you will find that a sequence may converge to more than one point or may converge to every point of the topological space. Or it may not converge. For example, just we will see that the sequence 1 by n, that will not converge in discrete topology. And it will converge to every member of the set if we equip the same set of real numbers with indiscrete topology. So in topological, how that will happen, when I will come to that chapter, I will explain. But for that, you need to know that which type of basis members are going to generate those topologies. And K-topology, basically K-topology is collection of all open intervals of the type open interval AB along with the all sets of the form AB minus K, where K is this set. K is equal to 1 by n belongs to set of natural number. So the topology generated by B double dash will be called the K-topology on R. When R is given this topology, we denote it by RK. So I have discussed this point in previous lecture that the topologies of RL and RK are strictly finer than the standard topology on R. So first we have to compare RL lower limit topology on R with standard topology on R, and then we will compare K topology on R with standard topology on R. And the third part is that then we also need to show that the topology, I mean lower limit topology and K topology on R are not comparable, So one part in last lecture I have explained. Now let us proceed. So for this, okay, so one part we have already completed. Now I have already, I think in previous lecture I have compared RL lower limit topology with standard topology. Is it? याद है किसी को पिछली क्लास में क्या कराया था? लोअर लिमिट टोपोलॉजी को मैंने स्टैंडर्ड टोपोलॉजी से कंपेयर किया था, ठीक है? Now let us see today in today's class how to compare to show that the K topology on R is strictly finer than standard topology R. Let us do this part. Now I need. Okay, first we will do this one. So let me write it. Let me share screen. So I need to prove that RK is strictly finer. RK is strictly finer than standard topology on R. And standard topology on R. We need to prove this one. RK is strictly finer than standard topology. So RK is the terminology used for. RK means R equipped with K topology. R equipped with K topology. For this, we have, for our convenience, we have adopted this notation. This means, so we already know. So let us first recall what is the basis which is going to generate the K topology. So RK K topology is generated by basis given by, let me write here K, just to denote that it is going to generate the K topology. This one is basically collection of all those open intervals AB along with all open intervals of the type AB minus K. AB minus K. Is it? Where K is this set. 1 by n, where n belongs to n. And standard topology, always write what results we need to require. So R with standard topology. R with standard topology. So we know that the basis for standard topology let me write simply as B. Basically, this one is collection of all those open intervals where AB belongs to R. where AB belongs to R. Here also AB belongs to R. Also AB belongs to AB are real number. So this much information we have. And what result I need to use? Yes. Because here the basis of these topologies are known. So we will apply that lemma 13.3. What is that lemma? Recall. Yes, anyone? वे बोलते रहे तब तो क्लास इंटरेस्टिंग
हमको सर ये
क्या है? How to show that
yes sir,
T dash is strictly finer than T? Suppose topologies, if their bases are given, how we will show? We need to show that for each x belonging to X and each basis element, यही तो है, and each basis element
belonging to T dash,
B belonging to
T dash,
B containing X. There is a basis element B dash. There is, I mean, there is at least one. There is a basis element such that X belongs to B, sorry, not this one. These are the basis member basically here. So I need to write it as X belongs to B and B dash is contained into. So this will be given to you, this will be given to you. One need to check whether this is stand or not. Okay? Then if this happens, then the topology generated by the basis containing the members of this type B dash is going to be finer than this one. Then we will see that T dash is finer than, strictly finer than T. So here I need to show that T dash is strictly finer than T. So what I will do, in place of T dash, I need to write RK. Just compare it in place of T dash because I need to show that the K topology is finer than standard topology. I simply write R. Whenever I write R means I am talking with respect to the standard topology on R. Now the result is given to you. One need to apply, and the basis members are known, which is going to generate these topologies RK and R. And this is the required result which I need to prove. Now think on it. Results is given to you. Then I will discuss. So let us take any member. Let us start from say X equal to 0. 0 is a real number. So let me check this X. Let me take this X as 0 and just check whether this, for all those basis member which contains 0, whether B dash exists or not. सोचो आप इस पे, फिर उसके बाद बात करते हैं. मैं टाइम देता हूं, आप देखो पहले.
सर कंटेन तो नहीं होगा सर.
कंटेनमेंट नहीं होगा. किस तरफ से कंटेनमेंट नहीं होगा? अच्छा, आर्किमिडियन प्रॉपर्टी ऑफ रियल नंबर सबको मालूम है ना?
यस सर.
यस सर, पता है.
मैंने रियल में बहुत पढ़ा रखा है. रियल में भी, मैट्रिक में भी पढ़ाया था. आप लोगों को लेक्चर भी शेयर किया था. ठीक है
सर.
हाँ, बताएं
सर, अगर हम एलिमेंट ले लें 0 और के टोपोलॉजी का एक हम बी बेसिस ले लें इंटरवल -2 से 2 -k वेयर k 1/n नेचुरल नंबर, तो इसमें 0 एग्जिस्ट नहीं करेगा. फिर
ओके,
कोई इसमें ऐसा इंटरवल ही नहीं मिलेगा जो इसको 0 को कंटेन करे.
बताऊं सर, कंटेंट हो गया है कि
okay, let me divide it into two parts. Let us start step by step. I need to prove, let us do both sides. I mean, on one side, we will check that RK, I mean, K topology on R is strictly finer than the standard topology. And on one side, I need to show that R is not strictly finer than, I mean, standard topology is not strictly finer than the K topology. समझ में आया आपको? मुझे दो पार्ट प्रूफ करना है, ठीक है ना?
यस सर।
क्योंकि इसमें वन साइड लिखा हुआ ना, आर के स्ट्रिक्टली फाइनर देन स्टैंडर्ड टोपोलॉजी, तो दूसरा भी तो देख चेक करना पड़ेगा, ठीक है? अब देखो एक एक करके चलो,
वाला नहीं होगा सर।
यहाँ पे आपको रिजल्ट दे रखा है, इसको अप्लाई करना है। So to compare that T dash is finer than T, we need to show that for each X belonging to the topological space and for all basis member containing X from the basis which is going to generate this topology T. So I need to show that for every X belonging to R, because here space is R basically, and for each basis from which topology? Standard topology. For each basis generating standard topology and containing X. Now, what are those? See, in general, you can write AB. I mean, for all basis from standard topology. The basis for standard topology are this type. So for, or in general, you can write here X minus epsilon, X plus epsilon. Because we already know the sum of two real number and difference of two real number is just a real number. And if someone asks you that we are just provided R with a topology, then why you are using this minus notation and plus notation? Because we have not mentioned that whether it's a vector space or not. So in that case, just you can assume that X minus epsilon is, you can call A, and this you can call as B. So this is just a representation. Okay. So for all those basis member containing X, obviously X will be member of this type, X minus epsilon, X plus epsilon. Hoga na X? Now can you think here a basis member from the standard topology which also contains X and is contained into this interval X minus epsilon, X plus epsilon, or say AB. क्या आप बता सकते हैं कि ऐसा हमेशा कर सकते हैं?
Yes sir.
You can see that one can always do this. See, this one is given to you, this one is given to you. You need to find this one.
Yes sir.
Is it? ये तो definition demand है ना. ये आपको X दिया होगा, B दिया होगा. For all B containing X and for all X belonging to X, we need to check whether this B dash exists or not, which contains that X and which is contained into B. तो कैसे आप कंस्ट्रक्ट करोगे? मैं ये तो कर सकता हूँ कि नहीं? X minus epsilon by 2, X plus epsilon by 2, which is sitting inside X minus epsilon, X plus epsilon. ये लिख सकता हूँ कि नहीं मैं?
यस सर, कर सकते हैं।
ये तो आर्बिट्री किसी भी X के लिए ट्रू है ना?
यस सर।
ठीक है, तो ये साइडेड तो हमेशा ट्रू है, ऐसा कहीं फेल तो हो नहीं रहा, क्योंकि इस तरह के जितने भी ओपन इंटरवल एबी टाइप के, आई मीन ऑल फॉर ऑल दोस ओपन इंटरवल्स बेसिस मेंबर्स ऑफ द टाइप ओपन इंटरवल एबी कंटेनिंग एक्स, वन कैन ऑलवेज कंस्ट्रक्ट दिस वन. दिस यू कैन आल्सो सी ऑन द लाइन, से दिस, इफ दिस इज एक्स, दिस इज योर A, this one is B, then I can always choose another basis member. See, this type of basis, actually your K topology will contain basis member of open interval AB as well as AB minus K. So at least one we have from this basis, at least one we have here. This comes from the K topology, this comes from K topology, and this one is the basis for this is coming from standard topology. So there is no problem here, I think. Now, how to show that standard topology is not finer than K topology? Question is how to show that standard topology is not finer than K topology. Okay, let me start. Let me take X equal to 0 and just apply this definition. I am saying that, see, what are the basis member from?
Sir, एक example लेके कर दें.
Yes, what are the basis member from K topology which contains the. Now let me construct. Let us think of all those basis member from K topology, from the basis generating K topology. So basis containing basis of this K topology will be is of the type open interval AB or AB minus K. So let me write here AB. This is from K topology. And obviously AB minus K. AB minus K. We need to check for all basis elements containing this. We need containing 0. So to explain, and I need to find here basis which also contain basis from standard topology which also contains 0 and which is contained into this one. This is our aim. So for understanding purpose, let me denote this open interval AB. Let me simplify this. So in place of this, I can write here. Okay. To make it more clear, I can write here. You can take 0 minus epsilon, 0 plus epsilon, and 0. Let me replace this AB by 0 minus epsilon, 0 plus epsilon. And this one by 0 minus epsilon, 0 plus epsilon, minus K. Now think of, is this definition true for all the intervals of this type and this type? I mean, can you find always an open interval from the standard topology which contains 0 and which is sitting inside this basis member, and all these basis member which contains 0? ठीक है, बताएं इस पे. देखो यहीं पे आंसर है. अब ये आप अगर
नो सर,
कहाँ प्रॉब्लम होगी, किस तरह के बेसिस एलिमेंट में प्रॉब्लम होगी? देखो इसके साथ तो ऑलवेज ट्रू हो जाएगा, यहाँ पे तो ट्रू होगा, क्योंकि यहाँ पे आप ले सकते हो 0 माइनस एप्सिलॉन बाई 2 और 0 प्लस एप्सिलॉन बाई 2 ले लो, तो ये दिस विल बी ऑलवेज कंटेन इनटू 0 माइनस एप्सिलॉन 0 प्लस एप्सिलॉन.
सर ये के वाला प्रॉब्लम करेगा.
हाँ, ये के वाला प्रॉब्लम करेगा. ठीक है,
ये कंटेंट नहीं होगा सर.
हाँ कंटेंट नहीं होगा. मैं इसको मिटा देता हूँ. ठीक है, मैं यहाँ लिख देता हूँ, जगह नहीं है यहाँ पे. एक काम करता हूँ, मैं इसको थोड़ा सा और क्लियर कर दूं इसको. तो हमेशा देखो क्या किया करो ना, डेफिनेशन जो है आप पहले लिख लिया करो, क्या क्या रिजल्ट आपको यूज करने हैं, किस तरह के बेसिस मेंबर से जो उस टोपोलॉजी को जनरेट कर रही है, उसके बाद आप स्टेप बाय स्टेप कंपेयर करें. कभी भी प्योर मैथमेटिक्स पढ़ो तो आपको जो डेफिनेशन इसे स्ट्रिक्टली फॉलो करना है. बार बार मैं पहली क्लास से ये बात कहते आ रहा हूँ. अगर आप डेफिनेशन मिस करोगे तो हम रिजल्ट कहीं भी अगर आपको दिक्कत आ रही है, इसका मतलब आपने डेफिनेशन सही से समझा नहीं, या फिर कहीं ना कहीं कुछ प्रॉब्लम है. डेफिनेशन आप रिकॉल कर लिया करें. तो मैं ऐसा करता हूँ, मैं इसको यहाँ एक्सप्लेन कर देता हूँ. I'm saying that for every basis, for every B belonging to BK containing 0, is there, you can call it BK, is there basis from standard topology, is there basis, let me write here. My question is there always a basis from standard topology which is contained in BK? Is there always a basis containing 0 from standard topology? लिख दूं ताकि बाद में जब आप इसे रीड को समझ में भी आए. And my question is that let me fix x equal to 0. Then for all basis members of the type open interval AB or AB minus K containing 0, because this should be true for all basis members from the K topology containing 0. So can I always find open intervals of the type AB from standard topology, which is this one? If it fails for any basis member from the K topology, then this containment is not possible. So for that, let me take this one. Let me replace AB by say 0 minus epsilon 0 plus epsilon minus k. Okay. Now, can you have this one? Now tell me here a basis member containing 0 from the standard topology which is sitting inside this one. बताएं आप. Yes, internals आपको करा चुका हूं कई बार. मैं रियल एनालिसिस में मैंने कई बार एक रिजल्ट यूज किया है.
नहीं होगा सर.
कोई इंटरवल ही नहीं मिलेगा सर.
नहीं, क्यों नहीं मिलेगा? लॉजिक बताओ ना. ऐसे कहने से थोड़ा ना मिलेगा कि जबरदस्ती कि नहीं मिलेगा.
लॉजिक ये सर, लॉजिक सर कोई भी इंटरवल लेंगे सर, ठीक है, और हमने दूसरा इंटरवल जो माना जिसमें से हमने फाइनाइट नंबर माइनस किए हैं, जैसे 1/2, 1/3, तो अब जो इंटरवल है उसमें से
जस्ट लिसन इज दिस सेट फाइनाइट? हां,
नो सर, इट्स नॉट फाइनाइट. वो निकल गया सर. मैं ये कह रहा हूँ के टाइप्स के जो एलिमेंट होंगे 1/2 या 1/3 वो माइनस कर दिए इस इंटरवल से, और हम ये क्लेम कर रहे हैं कि क्या इसी इंटरवल में वो इंटरवल कंटेंट होगा. तो ये सर पॉसिबल नहीं है सर, क्योंकि वो पॉइंट्स उसमें से निकल जा रहे हैं.
नहीं, ये जो आप फील कर रहे हो ना, इसे एक्सप्रेस कैसे करोगे
सर? ये फील कर रहे हैं, इसको एक्सप्रेस कैसे करें?
भाई मैथमेटिक्स में कोई रिजल्ट है? क्या नाम है आपका
सर?
नहीं, नाम बताओ. देखो क्लास इंटरेस्टिंग तभी होती है, नाम बताएं. हाँ, क्या नाम है? तो ऑनलाइन क्लास में
मोहम्मद रेहान रजा.
हाँ, रेहान रजा. ठीक है रेहान, अच्छी बात है जो आप पार्टिसिपेट कर रहे हैं. देखो टीचर के लिए बात ये नहीं कि आप हर सवाल सही का जवाब दे दो. चलो ठीक है. तो प्रॉब्लम समझ में आ गया आपको? क्या दिया हुआ है? 0 is given to you and for all basis member.
जैसे
Rehan, let me explain. For all basis member from the K-Topology, look here, basis member from K-Topology are of the type open interval AB or AB minus K. So let me replace this AB as 0 minus epsilon and this B as 0 plus epsilon, where epsilon is greater than 0. So now for this interval, see for this open interval 0 minus epsilon, 0 plus epsilon, it's okay. One can always construct interval of this type. There is no problem. But for basis member of this type, around 0, if we take any interval of this type, 0 minus epsilon, 0 plus epsilon minus K, then from Archimedean property of real numbers, one can never have any basis element of the type open interval AB containing 0 and contained into this one. Why? Now, for that, you have to claim Archimedean property of real numbers. Now, let me remind what I mean by Archimedean property of real numbers, and all those students which are new to this batch, revise all those lectures. Those are already available on my widget playlist, and there I have already explained in detail how to show that in every neighborhood of 0, there will lie infinitely many members of the type 1 by n. So let me recall here the statement of that this Archimedean property of real number. So Archimedean property of real number. Actually, this containment is not possible. Let me write here that this containment is not possible. Why? For this, you have to put Archimedean property of real number. Archimedean property of real numbers. It says that for every epsilon greater than 0, epsilon is some real number, there exists a not belonging to n such that 1 by n can be made less than epsilon for every n greater than equal to n. This is the basically that standard result which I need to quote in claiming that around each basis member of this type containing 0, one can never have an interval of this type open interval AB containing 0 and contained into this one. Why? Because see, let me also, for example, what I mean here that for every epsilon greater than 0, so I can also express it as this. My claim is that here that, see, whatever epsilon you choose, any this for all those interval of the type 0 minus epsilon, 0 plus epsilon. I mean for this fixed n naught, for all those n greater than equal to this fixed n naught, 1 by n, see 1 by n is not going to be negative because n belongs to n. So this is a non-negative number, so it will lie right to 0. So here the 1 by n elements will lie, whatever epsilon you choose in between 0 to epsilon. How many choices we have for this 1 by n? How many choices we have? This is true for all n greater than equal to n naught. There are counting infinite choice. How many choices we have for this n?
Infinite choices.
Infinite choice. So in every neighborhood of 0 to epsilon, in every neighborhood of 0, say, I mean 0, in between 0 to epsilon, there are infinitely many members of the type 1 by n. Whatever epsilon you choose. So what I have done here, that whatever epsilon I choose, in every, if you delete this k 1 by n, if I remove this 1 by n, because whatever interval you choose here, 0 minus say epsilon dash and 0 plus epsilon dash, because I already taken here epsilon, so let me write, so, and just replace this epsilon by epsilon dash. So for every, in between every interval 0 to epsilon dash, there lies infinitely many members of the type 1 by n. There lies infinitely many members of the type 1 by n. So whatever interval you choose here around 0 of this type AB, it will always contain elements of this type 1 by n, and here we have removed the element of 1 by n. So this set is not going to be contained into this one. Is this clear to everyone?
सर
हाँ
सर, अगर हम इंटरवल 0 माइनस एप्सिलॉन से 0 कर लें तो कंटेन हो सकता है, क्योंकि ये k की वैल्यू तो पॉजिटिव आएंगी। 0 माइनस एप्सिलॉन से 0 तक, तो ये इंटरवल तो आ सकता है उसमें।
क्या नाम है? शारिक।
यस सर। आप
इंटरनल हैं?
यस सर।
इस टॉपिक को मैंने इतना ज्यादा डिटेल में पढ़ा है, कम से कम इसमें मैंने 20 लेक्चर आपको सिर्फ इस पर्टिकुलर टॉपिक पे डाल रखे हैं यूट्यूब पे, और
सर,
फिर भी आप ऐसी बातें कर रहे हो।
बोला सर k है, k की वैल्यू हमेशा 0 से पॉजिटिव आएगी क्योंकि उसके लिए एप्सिलॉन एग्जिस्ट कर रहा है। तो सर अगर हम माइनस एप्सिलॉन से 0 का इंटरवल लें।
अच्छा ठीक है शारिक, एक मिनट, आप जो बात कह रहे हो ना पहले मैं लिख दूं, वरना फिर आप अपनी बात से मुकर जाओगे। मैथमेटिक्स से पॉलिटिशियन का तो है नहीं ये क्लास। ठीक है, आप जो बोल रहे अच्छी बात है, चलो आप पूछते तो मैं दोबारा कहता हूँ, मैं लिख देता हूँ। ये तो समझ आ गया हमें क्या पर्पस, यहाँ मिटा दूं इसे मैं?
यस सर, यस सर।
ठीक है, चलो अच्छी बात है। सॉरी, ओके, ये तो मैंने टोटल मिटा दिया। ये है ऑनलाइन में, एक क्लिक पे जितना लिखा था सब कुछ मिट गया। चलो ठीक है, देखो आर्किमिडियन प्रॉपर्टी ऑफ रियल नंबर, क्या करना क्या था हमें? फॉर ऑल दोज बेसिस मेंबर ऑफ दिस टाइप से 0 माइनस एप्सिलॉन, 0 प्लस एप्सिलॉन माइनस k, where k is this set, say 1 by n, n belongs to n. I need to find interval of the type AB which is sitting inside this one. I need to find here, basically this is the question, because I need to find here intervals containing 0 and which is contained into this one. This basically this is member of the basis which is going to generate the standard topology.
Yes, sir.
Okay, and we know that Archimedean property of real number, Archimedean property of real number. Archimedean property. Statement of this is that for every epsilon greater than 0, there exists n naught belonging to n such that 1 by n is less than epsilon for every n greater than equal to n naught. हाँ शारिक, ये तो आर्किमिडियन प्रॉपर्टी। अब आप बताएं क्या कह रहे थे, मैं लिख दूं यहाँ पे। हाँ क्या कह रहे थे आप, बोल रहे थे?
माइनस एप्सिलॉन से 0 का इंटरवल।
माइनस एप्सिलॉन से 0 का इंटरवल, हाँ
सर ये हमने सर इसमें के इनफाइनाइट टर्म्स हटाए हुए हैं जो कि 0 से पॉजिटिव की तरफ है, तो माइनस एप्सिलॉन से अगर 0 लेंगे तो सर इसमें आ सकता है कि नहीं?
पहले 0 इसमें कहाँ आ रहा है? आपको तो वो सेट लेना है ना जो 0 को पहले कंटेन करे और फिर इसके अंदर कंटेंट देखना है ना। इसके अंदर 0 कहाँ है? और आप क्लोज यहाँ कर नहीं सकते, आप ऐसे समझो, ज्योमेट्री भी देखो, ये 0 है, ठीक है, आपने कोई भी एप्सिलॉन ले लिया, चलो मान लो माइनस एप्सिलॉन, 0 माइनस एप्सिलॉन, 0 प्लस एप्सिलॉन है ना, ये ए बी।
यस सर।
तो अब ये मान लो इसको ए है, ए एंड बी है, तो अगर 0 को कंटेन करने का कोई भी आप इंटरवल इस टाइप का लोगे, ओपन इंटरवल ए बी, तो दिस इज नॉट ऑफ दैट टाइप। व्हाई? बिकॉज इट इज नॉट कंटेनिंग 0।
यस सर।
नाउ इफ we need an open interval which contains 0. So you have to go to
Yes,
right some right of this
okay,
0.
okay, yes sir.
And let me call this epsilon dash.
Yes sir.
Okay. Now just replace, because for epsilon is a real number, and for every epsilon this is true, that in between 0 and epsilon, there are members of the type 1 by n, and we have here
Yes,
infinite choice. So whatever epsilon dash or epsilon you will choose here, just note it.
Yes, sir.
Always we have here 1 by element of the type 1 by n.
Yes sir, we have to remain finite in trees.
है ना, ठीक है?
Yes sir.
Infinite choice.
Okay.
ठीक है, कोई बात नहीं, आप दोबारा पूछ लिया करो. अब वो होता है ना, मेहनत से पढ़ाते हैं तो इंटरनल का नाम सुनते एक्सपेक्टेशन ज्यादा रहती है ना.
ओके सर.
ठीक है, तो उसमें कोई बुरा मानने की बात नहीं है. नहीं आया दोबारा पूछ लिया करें. देखो इसको मैं एक और, जो लोग शायद पहला लेक्चर इससे पहले पता नहीं आर्किमिडियन प्रॉपर्टी ऑफ रियल नंबर पढ़ा है कि नहीं पढ़ा है, मुझे नहीं मालूम. लेट मी explain here with the help of example. See, this is true for every epsilon.
Yes sir.
So for that, let me take epsilon is equal to, say 0.333.
Yes sir.
So I can always find n naught such that for all n greater than equal to that n naught, 1 by n will be always less than epsilon. My claim is that one can choose n naught is equal to 1 by epsilon. Let me take its ceiling value. That will be 4. So for every n greater than equal to 4, you can check. For every n greater than equal to 4, you can check. This one is
Yes,
just n naught. That 1 by n will be always less than epsilon. I mean, this 1 by epsilon is 0.33. If I put n equal to 4 here, then 1 by 4 is 0.25.
Yes,
and 0.25 is going to be less than 0.33.
Yes sir.
Now take n is equal to 5. So 1 by 5 is less than 0.33.
So
take n equal to 6. So
yes,
we have at least one n naught. Whatever epsilon you choose, we always have at least one n naught, such that after that for all n greater than equal to n naught, 1 by n will be always less than epsilon.
Yes sir, एक natural number मिल गया.
Yes, we can say that in between 0 to epsilon, whatever epsilon be,
yes,
we can
sir.
always have members of this type. ठीक है ना? तो यहाँ कोई 0 को कंटेन करने वाला अगर मैं कोई भी इंटरवल लूं तो उसके अंदर ऑलवेज 1 by n टाइप के मेंबर होंगे. सिंपल वर्ड में बात करें तो 1 by n
yes,
होंगे. और यहाँ
yes,
बाहर कर दिया तो ये सेट इसके अंदर एक भी एलिमेंट इसका अगर इसके अंदर नहीं होगा, सेट थ्योरी में क्या करते हैं, कैसे दिखाते हैं, एक इज कंटेनिंग टू बी. दिस मींस फॉर एवरी x बिलोंगिंग टू a implies
yes,
x belongs to b. तो अगर एक भी एलिमेंट फेल कर गया तो ये नहीं होगा ना कंटेनमेंट पॉसिबल.
यस सर.
ठीक है, डाउट तो नहीं आता किसी को?
नो सर. थैंक यू सर.
ठीक है, मैं लेक्चर यहाँ आज रुकता हूँ, असल में एक मीटिंग है. ठीक है, तो आप इसको रिवाइज कर लें, कल मैं यहाँ से दोबारा आगे बढ़ूंगा.
यस सर, थैंक यू सर.
ठीक है.